Okay, today we continue our foray in the second unit, solving equations or linear equations in one variable. So your TOC for today, unit 2, 5 steps for solving equations, examples for 1 and 2 step equations. And we're going to start on page 26. And I think we may only need 27, but I wanted to leave that open because we may wind up going on to part of 28. Okay, so that's your TOC. Let's get that written down. Okay, so moving on. Five steps for solving equations. Starting on page 26. Okay, 5 steps for solving equations. Now, this is not the end-all, be-all in terms of the order in which you can do things to solve equations, but it is a beginning path, right? When we're solving equations, it's not good enough to just say like, oh, because I know, or because of this. You need to maintain equality using the properties of equality. You need to be able to justify what you're doing using the tools that we talked about yesterday, such as the multiplicative inverse, the additive inverse, and the different properties of equality that we went over. And this is kind of like an initial path to get to our ultimate goal, which your ultimate goal in solving equations is to find out if there is a balance for the variable that would make this true. Okay, that's not always going to be the case. There'll be some special cases where there'll be more than one choice there, or there'll be no choices. But usually, typically, we want to find the one value that when we substitute it in for the variable, creates a true mathematical statement. So step number 1 is going to be distribute. Okay, and distribute is use distributive property to eliminate grouping symbols. And again, like I said, this is not the end all be all. So when we say distribute, what we're really talking about is usually we're going to use distributive property to eliminate grouping symbols. Sometimes we might use some other things. Sometimes we might, if for example, have a grouping symbol that is a fraction bar. So there may not be distributive property there. We may need to eliminate the fraction. So that's kind of like where we are. An example is if we have 2 times 3x plus 1. Remember, based on what we talked about yesterday, 2 can be multiplied by each individual term within the parentheses. And we would still get the same thing as if we added these 2 terms together, which we can't right now because there's a variable involved. So we're going to wind up with 2 times 3x plus 2 times 1, giving us 6x plus 2. Step 2 is combine. And we're talking about combining like terms. And you might say, what is a like? And we often abbreviate this as CBLT. So to be alike, what are the rules? Because there's rules that need to be met. A, to be alike, I guess A, fixed numbers, always alike. An example of this would be like 3 plus 7. Like those two things are alike. Anything that's does not have a variable with it is considered a fixed number. So those would be alike. And then variable terms, Zeus, be quiet. In order to be alike, we need to have identical variable or variables, and the variable or variables have to have identical exponents. Okay, so if alike, combine the coefficients. So some example of that, if we have 2x plus 3x, that can be combined to make 5x. If we have 2 plus 3, that can be combined to create 5. If we have 2xy plus 3xy, that means we have 5xy's. 2xy plus 3x plus 2, there's no combination here, right? Because this is a fixed number. And while these are both variable terms, this has an xy and this just has an x. So they cannot be combined. Step 3 is rewind. So this is where that multiplicative inverse and the additive inverse are going to be used. Hold on for just 1 second. I'm letting my dogs out. They can stop barking while we're doing the video. That's a quick let your dogs outside so we don't have to talk over their barking, kind of like when the bell rings at school. So undo terms by going backwards through the order of operations. We use our inverse chart, which remember we did yesterday, to guide us. And step 4 is to solve. That means we have one variable equal to usually a fixed number, right? But then we also have 2 special cases, but this is the usual. Two special. 2 special cases can be no solution and infinite solution. But we're going to talk about these later. They'll still involve the 5 steps for solving equations, but we'll find out that when we get down to the solve, it's going to look a little bit different. And lastly, we need to check, which is to check your work. By substituting the solution from step 4 into the original equation. If the solution is correct, a true statement will be created. So let's just talk for a minute about kind of what is the goal of these steps, right? What is the goal? So for distribute, our goal is to get things down to terms. Terms are separated by addition and subtraction or the equality sign. Okay, so goal to have all terms in the equation. Okay, step 2, the goal is to get down to one fixed and one variable per side max. And what that means is that the maximum allowed on each side of the equal sign is one fixed number and one variable term. That's what it would mean to combine like terms. We've gotten it down to maximum 2 terms on each side of the equal sign. Now, that may not always occur. You may not have variables on both sides all the time. You may not have fixed numbers all the time on one side, and that's okay. So we have accomplished this when our maximum amount on each side is one fixed and one variable term. We'll put terms. Okay, rewind. The goal is to have one variable term equal to one fixed term. Now, remember, we talked about the transitive property yesterday. So it's okay if this is flipped around, where we have one fixed term equal to one variable term. And then the solve, the goal is to have a variable with a coefficient of 1, not -1, 1, equal to your fixed number. And we'll find when we talk about cases over here, that's not going to be a possibility. This isn't what our solution will look at when it's a special case. But 90% of the time, it's not going to be a special case, right? Because special means not occurring all the time. It's usually going to be one variable with a coefficient of 1 equal to a fixed number. And check, our goal is to make sure we did it correctly, right? But think about these goals as we're accomplishing the different steps for solving equations. Now, today we're going to look at a few 1-step and 2-step equations, just kind of to refresh our memory. So these are ones that are currently on your GPs. Okay, so you're going to have, I'm going to not do all of them. I'm going to do a couple questions from your different GPs that you have in your digital book. And then the rest you'll have to complete on your own. So you have GP2 and GP3 to do today. So let's just look at from GP2. If we have x plus 9 equals 3, we can see we don't have any distributive property. There's no grouping symbols. We don't have any combining like terms because we don't have two of the same type of term on either side of the equal sign. We do have some inverse operations. So if I want to get x by itself, that means I need to rewind the positive 9. How can I do that? I can use its additive inverse and put negative 9 on both sides. Positive 9 and negative 9 cancel out, leaving me with x equal to negative 6. So I just executed essentially a step 3 or an inverse step. I'm sorry, a rewind step. And this is the solve step. And then I want to check my work. So negative 6 plus 9 equals 3. Negative 6 plus 9, that does equal 3. I've created a true statement, so I know that I've done this correctly. If I am looking at, and I know I'm putting 3 because remember, I'm not doing all the problems on the page. Negative 4z equals 48. Negative 4 and z, they're multiplying together. And my goal would be to get down to 1z or 1 times z. So how do I take this negative 4 and get down to the multiplicative identity of 1? Well, I'm going to multiply by its multiplicative inverse. So as a fraction, this would look like negative 4 over 1. So I'm going to multiply by negative 1 over 4. So negative 4, negative 4. This will simplify out to be 1. So I'm left with 1z. 48 times negative 1 is negative 48 over 4. And when I simplify that, I would get negative 12. So if I check my work, negative 4 times negative 12 equals positive 48. A negative times a negative is a positive. 4 times 10 is 40. 4 times 2 is 8. So 48 equals 48. True statement. Number 5. 5 over 6m equals 10. So again, if I want to get rid of this, there's two ways I can approach it. I can approach it as m is being multiplied by 5 and divided by 6. M is being multiplied by 5 and multiplied by 1/6, or m is being multiplied by 5/6. So just like here, I use that multiplicative inverse. I'm going to do the same thing and find the reciprocal, what I call the refliprical of 5/6, which would be 6 over 5. Now I'm going to multiply both sides by that. Over here, 5 divided by 5 is 1. 6 divided by 6 is 1. So this winds up to be 1m. Over here, I wind up with something that looks like this, 10 times 6 over 5. If I put that 10 over 1 and I apply the fraction rules here, I can cross this out to be 2, and 2 times 6 is 12. Okay. There's another interesting way that we can actually do that problem. We're going to talk about that. So 5 over 6 equals 10. One approach I could get is I can get rid of the fraction. And I can do that by multiplying the whole thing by the GCF of all the fractions. Since I only have one, its GCF is actually the denominator. So 6 over 1. And if I do that, this cancels out, leaving me with 5m. And 10 times 6 would give me 60. I could then multiply both sides by 1/5 and get m equals 12. So that's another way to eliminate it kind of in 2 steps rather than using just the straight multiplicative inverse. Okay, two-step equations basically are the same thing. They just, instead of taking one step to solve, they take two. So if we have 4y minus 4 equals 16, this is number one on GP3. I ultimately want to solve for this. Again, no grouping symbols, no like terms over here, no like terms over on this side. So then I go to the rewind step. So if my goal is to get y by itself, right, I first want to eliminate the term that's not part of the variable. So the opposite of a -4 is a +4. 4y, I haven't done anything to that. -4 and +4, they're additive inverses, so they simplify out to be the addition identity of 0, and equal to 16 plus 4 is 20. Then I can multiply both sides by the refliprical. Remember, 4 over 1, its refliprical would be 1/4. In other words, multiplying by 1/4 is the same thing as dividing by 4. So eliminates out to be 1y, and 20 divided by 4 would be 5. And if I wanted to check that, in fact, if I wanted to check any of these, I can do the check step. Whether I do it on paper in my head is up to you. So if I put it back in, 4 times 5 would be 20. 20 minus 4 would be 16. And I've come up with my answer. So two-step, we're literally just kind of adding what we did together. We did something similar to what we did here in 1, and then what we did here in 3. But we had to do both of those steps since both of these existed on one side. And that is the 5 steps for solving equations. I'm also hopefully going to be able to put a video in tomorrow when I'm at school, a real quick video, and show you in class. We have some hand motions that we like to do for the 5 steps for solving equations, and that's why we call them distribute, combine, rewind, solve, and check, to help you remember one of the paths that you can take when you're solving an equation. So make sure you put your notes in and make sure you update your digital notebook. Have a great night.